So our previous lesson, okay, we already learned based on to the concept of the three of the gas, which is a boys, Charles, and avocado. Okay, so for right now, before we start, you have a problem according our previous lesson for these exercises. So you must be pass up bila ya? Hari ni last kan? Betul? Malam ni ada masalah tak? For this
Ada.
exercises question, yeah.
Kalau dia bagi
Uh-uh.
dua pressure kan, satu pressure tu unit
Uh-uh.
lain, satu pressure tu unit lain. Nak kena samakan
Okay.
unit dia.
Yes, kena samakan sebab dia adalah ratio punya step. So if a ratio, we must similar samakan kita punya unit. So basic unit adalah ATM. Okay, sebab bila kita tahu our conversion unit page tu 1 ATM, kalau dia ke dalam mmSg bersamaan dengan 760. Kalau dia kepada TOR 760. Kalau Pascal 101,325. So convert lah kepada ATM first. Must disamakan dia punya ni unit ratio. So malam ni last Okay, so kita fokus for lesson hari ni. Sekejap. Okay, so this lesson we are focused on the ideal gas equation. In ideal gas equation, we are combined according to the three theory, Boyce, Charles, and Avogadro, and we substitute together because we have a similar variable as a volume. And when we rearrange, finalize, we can have the one constant as the R. So this is why final equation we use, which is we call PV equal N RT. So this is belong to the R constant, which is the constant based on to the ideal gas constant. So this unit for R constant are different if we have a different unit pressure and volume. So if you refer to the our book, page number 2, so in page 2 we have a 4 value of R constant, two same value but they are different unit. So according to PSPM, the table of the constant given similar in our book. So which one is the mostly used? The value of R is 0.08206. This is the familiar we use for this our calculation because if we want to use for this value, the pressure must be in ATM, the volume must be in liter. So this is why the unit of our constant is liter ATM per mole per Kelvin. If we use 8.314, the volume used is per meter, okay, meter cube, and the pressure is Pascal or Newton per meter. So this is difficult to you to convert the unit lah. So if we use 62.36, pressure dia adalah mmSg ataupun torr, volume dia must be in liter. So but the first value I already used during calculation. So when we go through here, how we can get the data 0.08206 liter ATM per Kelvin per mole, because at STP we have the constant data, temperature is 0 degrees Celsius, pressure is 1 atm. So, and mole is 1 mole. When we substitute into the ideal gas equation, finalize, we can get the R constant value, which is 0.08206. So what is the application for this formula? We can calculate together the value of molar mass of the substance. We already applied in our experiment, okay, which is the experiment 2. So the starting from the formula PV equal nRT, when we have the mole equal to mass over molar mass, we substitute the formula M over MR, we replace by mole RT, and we rearrange them. M molar mass is equal to the PV equal to the kita nak molar mass, right? So therefore molar mass is equal to the M RT over PV. So this is the finalist formula we use if we want to find out the value of molar mass. But the next application we can apply to find out the density value. So from this value, this of rearrangement of the formula, and we can substitute the volume at here. So M over V is density. So this is why the unit of density we try to use. So we try for the first question here. Now we do it together. We have the gases with the volume 275 liter, okay, and the mass of the oxygen is 0.485 kilogram, and the target question, calculate the pressure of the oxygen gas if the temperature is a 29 degree Celsius. So what should you do? So we try to construct it first. In our tank, we have the unknown of the gas, but the volume of the tank is equal to the volume of the gases, which is 275 liter. Okay, and then we have the mass of oxygen. So the gas, we know that this is oxygen gases, oxygen gas. So the mass of gas is 0.485 kilogram, and at the same time we also have the temperature of the gas is 29 degrees Celsius. Calculate the value of pressure. So therefore, can we use the formula of the Boyle's law, pressure and volume? No. Charles also no. Why no? Because we have another variable based on to the mass of substance. Okay, so that So, by using the ideal gas equation, PV equal nRT, the target equation is the pressure of oxygen. So, times our volume is 275 liter. So, the equation is a mole. How you find out mole here? Macam mana dapatkan mole? From the value of mass, right? So this mass must be converted into molar mass, but we already have the formula PV equal nRT, and we substitute the formula PV equal to the M over MR RT. So substitute the mass first. So mass in kilogram. So saya write again lah. P oxygen times 275, and then the mass for here by using this formula 0 equal to 0.485 times 10 to the power of 3 gram, and our R constant 0.08206 unit liter atm per Kelvin per mole. Why I choose negative 0.08206? Because the volume is in liter. Okay, and then it must be time by temperature. Your temperature must be in Kelvin, 29 plus 273.15. So press your calculator. So can you get the similar answer as a 1.37 atm? Same or not? Is it same answer? Anis dapat the same answer tak Anis?
Tengah kira.
Tengah kira. Okay, try kira. Correct or not for the answer given for the question number 1? Siapa dah dapat? $1.37 done already?
Madam,
Mhm.
yang mass tu kita kena bagi dengan molar mass lah.
Mass tak payah bagi molar mass sebab dalam formula kita dah siap susun dah kat sini. Kalau you guna formula mol, you kena bahagi siap-siap. Tapi bila kita dah susun formula, terus masukkan mass over molar mass dalam formula.
Okay.
So means saya tertinggal satu, bahagi dengan molar mass dia. So molar mass sama dengan 2 darab dengan 16 gram per mol. Nampak serabut sikit, so saya buat semula lah. Okay, so the step calculation must be pressure of oxygen darab dengan volume 275 liter equal to the mass of oxygen 0.485 gram, time 10 to the power of 3 gram because the data given in kilogram times for R constant 0.08206 liter atm per Kelvin per mole, and for the last its time by temperature 29 plus 273.15 Kelvin over molar massnya adalah 2 times 16.0 gram per mole. So, similar answer or not?
Similar.
Okay, good. Similar answer. Correct lah. 1.37 atm. When we go through to another question, number 2 and number 3 is same concept. So, we proceed to the question number 4. Example 4. Okay. So, we read the question together. Calculate the density. So, dia nak minta density unit dia gram per liter. Okay, for the carbon monoxide gas. Okay, but the first condition is at room temperature. Any data? According to our previous question number 1, all the data already given. But for question number 4, the keyword only room temperature. So, how you find out the data, the room temperature? Okay, so this density can be come up from the ideal gas equation. So we rearrange the formula first. So we can find out this our density, and the formula can find pressure, the relationship between density RT over MR. Okay, so we need to find the density. Is it we have any data for the pressure? Ada data pressure, ada data temperature, ada data molar mass. Nak guna kat mana? Mana dapat ada pressure value at room temperature? Apa maklumat tersembunyi dekat room temperature? Kamu tahu maklumat tersembunyi. Biasa
20 dia dah constant.
Constant value. What is the value at room temperature?
27,
24. 24. You are familiar with 24 this value. So this 24 units is liter per mole, but this is value we can call as a molar mass. Can we use for this data to find out the density? To find out the pressure, temperature and molar mass? No. So this is only the molar volume. So we have another keyword for here. At a room temperature, okay, we have the constant value. Temperature at a room must be 25 degrees Celsius, pressure 1 atm. So this is why we can get 24. And the molar mass of the substance monoxide adalah 12 plus 16. So therefore 28 gram per mole. So substitute for this value. So density Density equal to the pressure 1 atm time molar mass 28 gram per mole over RT. RT R 0.08206 liter atm per Kelvin per mole, and these are times by temperature. Our temperature is 25 plus 273.15 Kelvin. So what is the value? Press your calculator now. Is it the similar answer? Calculate now. So our finalized unit remaining, ATM cancel, mole cancel, Kelvin cancel, and we just have unit gram and liter. So this is the unit for the density. So the value is equal to Haziq. What is the value, Haziq? Is it same answer?
1.14.
Okay, good. Similar answer. 1.14 unit is compulsory gram per liter. Okay, now calculate for the STP. The next question for the STP value. Okay, so the density at STP, what is the data yang you need to find out? What is the value of temperature at STP, Azizi? Azizi, what is the value for temperature at the STP? What? Is it remain 25? At room temperature is 25. If the standard, what is the value?
Jawapan ni ke apa, madam?
I want to the temperature value. Temperature at the STP. Nilai temperature pada STP. Berapa nilai dia? Dekat room tadi 25. At room temperature, it must be 25 degree. So if the standard temperature and pressure, what is the value for temperature? It must be 22.4. Okay, 22.4 unit dia liter per mole. So this is molar volume. Cannot use in a unit PV equal nRT. So we need to use a formula. By using PV equal nRT, we already derive for this formula. Pressure density RT over molar mass. Which is formula dia pressure density RT over MR. Is it we have any formula or any formula for the unit molar volume? No. So we need to find out data, temperature, pressure and molar mass. So at the STP, temperature must be 0 degrees Celsius, pressure must be 1 atm. So if we use the same compound carbon monoxide, our molar mass is same 28 gram per mole. So we substitute into the formula, density equal to the pressure, MR, RT. So pressure is 1 atm, molar mass is 28 gram per mole, and R 0.08206 liter atm per Kelvin per mole, and the temperature also same, which is 0 degrees Celsius plus 273.15 Kelvin. So press your calculator, finalize, you can get the correct answer 1.25 gram per liter. Oh, sorry. Okay, get it? Okay, so I hope you need to try for an example 2, 3 and 5. Yes, any question?
Yang question A, room
Yes,
condition.
question A. Room condition.
Kenapa dia 25 degree?
Because suhu standard temperature, suhu bilik adalah 25. Suhu bilik.
Bukan 37 ke?
Berapa?
37.
27. 37 itu suhu badan manusia.
Oh,
Ini
right.
suhu bilik, surrounding. Suhu surrounding kita 25. Suhu badan normal kita 30 lebih, 35, 36. Ini suhu bilik, surrounding.
Okay.
Okay, alright. Okay. Tapi kalau STP, suhu dia kosong ya. So, every time you substitute, you must be convert into Kelvin. Okay. So, when we go through to our lesson, we have another two question. Example 3 and example 4. So, I hope you try include example 5, but I want you focus for this example. These exercises. So, macam biasa, hari ni you upload yang lesson semalam sampai pukul 12. Lesson hari ni you upload sampai hari Jumaat esok tengah malam. Kena apply. Alright? Okay. So, the last lesson hari ni, the last concept we can call as a Dalton's law. Dalton's law, the concept must be a mixture. So, our previous law, we already learned different container, different gases exist as a individually. So if I state that gas A is oxygen, gas B is the carbon monoxide, different container. But in Dalton's law, we are focused to the mixtures of the gas in the same container. So this is why Dalton's law focus on total pressure, means P total. Okay, so this total pressure is exerted by the partial pressure individually, means these gas are moved randomly and collect to the one container, and each can produce their own pressure. So for example, I label pressure for gas B, the blue color is gas B, and for the green color is gas A, collect to the one container, produce their own pressure. If both gas are in the same container, so the pressure exerted here we can call as a partial pressure because they are mixtures. So if they have a same container, we can calculate the total pressure by the addition of partial pressure for B plus partial pressure for A. Right? Okay. So this is why for each gases, the character dia must be, keyword gas tersebut must be non-reacting gases together. So if I have the container between, for example, gas hydrogen, and I also have gas oxygen. Hydrogen and oxygen can be reacted together or not? Fazira? Fast. Hydrogen gas and oxygen gas in the same container, boleh tak bertindak balas di antara satu sama lain? Can are reacted together? Can or cannot? H, hydrogen gas, H2, oxygen O2 are in the same container. Can are react to produce a new product? Can or cannot? Is it cannot? Can. It also can. The formation of water. H dengan O can be reacted menghasilkan water ataupun dia boleh juga menghasilkan H2O2. So therefore, this concept, the two mixtures of the gas cannot clarify as a Dalton. Syarat Dalton, dua gas tersebut mesti tidak boleh bertindak balas. Contoh gas apa? Okay, macam ni. I have a container. I have gas ammonia and also I have a carbon dioxide. Can the two gases compound reacted together? Sufi, can the two compound can reacted together or not? Ammonia and carbon dioxide, is it they react together or not? Sufi?
No kot.
Yeah, no. So, ammonia, dia tak boleh bertindak balas dengan carbon dioxide. Cuma, in the same container apa dia buat? Dia akan gerak, collect dua container, hasilkan pressure dia sendiri. Pressure ammonia. Carbon dioxide, collect dua container, hasilkan pressure dia sendiri. Ini kita panggil dia partial pressure. So, when the two gases are cannot reacted together, we can calculate the total pressure according to the partial pressure of carbon monoxide plus partial pressure of ammonia. Okay, we try to apply it, but this is the situation happen. Okay, the question is, when the three gases in the different container are mixed into the similar container, is that the pressure for the C, for the container A, And the partial pressure for C at the container B, is it the value for both pressure are same? Ke different? Udin? Udin ada Udin? Sekretari 15 cukup?
Yes, madam.
Ada tak? Okay. So, adakah nilai
Yes, madam.
pressure container A dengan container B, pressure C ni sama? Sama ke beza?
Tak.
Tak akan
Beza.
sama sebab container dia berbeza. Okay, pandai dia tu. Okay, next. Okay. So, therefore, disebabkan for each gases are ideal gas, so we can apply by using the ideal gas equation, PV equal nRT. If you measure for the gas A, means this mole or belong to the A. If we measure for the gas B, pressure for B, means volume same, mole are different. It must be mole B, are same, temperature also same, sebab condition they are same. And we mix together by the addition PA plus PB and we rearrange, this is your final formula. The total pressure is equivalent to the N total for here, right? Okay, next. And if we combine according to the mole only, so means dalam container kamu, I have gas A, gas B, gas C, and we just have mole for B, mole for C, and mole for A. Finalize, we can find out N total and we can find out the P total. Calculate the partial pressure for C. How you find out the partial pressure for each gas without any volume, any temperature? We can use the concept of mole fraction. So if you want to calculate the partial pressure for A by using the mole fraction for A, RT, sorry, mole fraction here, P total. So this mole fraction A, XA here belongs to the mole of A over N total. So you can substitute the data. Partial pressure for A can be calculated by mole for A over N total times P total. Similar for the partial pressure for B. If this formula used, they are in the same container. So basically, the total of mole fraction must be equivalent to 1. Okay, now for here. Try for the example number 1 sekarang. Example 1, we have same container, 2 different gases. Calculate the partial pressure and the total pressure for each gas. Now calculate here. So at the same container, the volume of container is 12 liter. Okay, we have the gas of nitrogen. So this is for the example 1. Gas nitrogen, we have the mass is 7 gram. And we have the CH4. The CH4 is 3.1 gram. Okay, so dia minta dekat sini, the temperature already given, 25 degrees Celsius. What is the partial pressure for each gas? So the gas are ideal gas. So by using the ideal gas equation, PV equal nRT. If the equation, if I want to find out the partial pressure for nitrogen, so therefore we need to find out the mole for nitrogen too. Similar for CH4. If I want to calculate pressure for the CH4, the volume container are same, mole are belong to the CH4, R constant also same, temperature also same. So what should you do here? You must be find out the mole for each gases. So calculate now. So step 1, mole for nitrogen. So 7 over 28. Berapa 7 over 28? 7 over 28. Berapa nilai mole you dapat? 0.25.
0.25.
Okay, good, correct. 0.25 mole. Okay, tolong saya kira mole for methane. Mole for methane, the mass is 3.21 gram. So 12 plus 4 gram per mole. So what is the mole for here? 3.21.
0.2.
Okay, 0.2. Okay, good. Okay, so what should you do if we have already mole? We already have the mole for each gases. So calculate one by one. Okay, I calculate first the partial pressure for the nitrogen. So the partial pressure for nitrogen times volume already give 12 liter. Mole for nitrogen is 0.25. R constant 0.08206 liter atm per mole per Kelvin, and temperature convert to Kelvin 25 plus 273.15. Okay, press your calculator now. What is the value for the partial pressure for the nitrogen? So I think same. The answer is 0.51. Is it correct for the answer for here? 0.51.
Sama.
Sama. Okay, good. So next, proceed for the CH4. We just replace by the mole for CH4. The another data are same. So the partial pressure for CH4, our volume are 12 liter. Mole for CH4 is 0.2 mole. R constant also same, 0.08206 liter atm per Kelvin per mole. So this is why you need to times plus by 273 for the temperature. 25 plus 273.15 Kelvin, and the partial pressure for CH4 is similar answer 0.41 atm. So now we proceed for the P equation, calculate the total pressure and the mixture. So P total equal to the partial pressure for the nitrogen plus partial pressure for CH4. So we just press your calculator. Nitrogen tadi 0.51, for the CH4 0.41, and finalize you can get 0.92 atm. So this is your total pressure inside our container. Okay, so example 2 now. Okay, if you're done, proceed to the second example, example number 2. Any question want to ask for the example 1? Okay, tak ada, proceed to example 2. Done already, yeah? Okay. So for the example number 2, the example number 2, we have the three mixtures of the gas which is neon. Neon, the mole given 4.53 mole, and the next we have the argon. Argon is 0.82 mole, and then we have a xenon 2.25 mole. At the same time, we have the total pressure. The total pressure here is equal to, the total pressure? Yes, 2.15 atm. Okay, the question is calculate the partial pressure of each gases. So from the mole, find out partial pressure neon. Okay, find out partial pressure argon, and also the partial pressure for xenon. Can we use the formula PV equal nRT? Can or cannot?
Cannot.
Why cannot? Why?
Tak volume.
Sebab volume tak ada, temperature pun tak ada. Kita hanya ada mole sahaja. So disebabkan mole, we need to use the formula mole fraction. So the first, I calculate the partial pressure for neon. It must be equal to the mole fraction neon times P total. Okay, so partial pressure for neon. So according to the mole of neon, so mole neon is 4.53 over N total. So we calculate first N total. N total must be 4.53 plus 0.82 plus 2.25. So this is the value of n total. What is the value for n total for here?
7.6.
Berapa?
70.6.
30.6?
7.6.
3.6. 3.60. Betul
7.
3. Ha? Tak dengar? Oh, 7. 7.60. Okay, 7.60. Okay. So maksudnya you akan over dengan 7.60 lah. P total kita dia dah bagi 2.15. So tekan calculator. Dapat tak similar answer? 1.3 ATM. 1.3 ATM, is it correct? Okay. So, if you want to calculate the partial pressure for argon, what is the value we need to replace? The mole for argon only. So, 8.82 over 7.60 times P total 2.15. So, the partial pressure also get 0.23 ATM. Is it correct answer? Okay. And for the finalize, for the partial pressure for xenon, similar step, substitute the mole, and you can get the partial pressure of here is 0.64 atm. Get it?